Here we're looking at problem 4 on the 6.5 worksheet. We're asked to find the rate of change of revenue and cost and profit, all with respect to time. So we have to remember that these are all assumed to be functions of time, so we'll have to be using the chain rule implicit differentiation for this. So the first one we'll do dr dt, derivative of the revenue with respect to time. So 50, the derivative of x with respect to time is dx dt. And then this one we use the power, we'll put the 2 in front, multiply by a half, that gives 1. Lower the power by 1, first power, and then we have to multiply by the derivative of x, that's dx dt. So that's the chain rule there. Okay, so we want to find the rate of this when x is 40 and dx dt is 25. So what we're after now is what is dr dt when x equals 40 and dx dt is equal to 25. So we'll plug those into here now. So 50 dx dt 25 minus x, that's going to be 40, and another dx dt there, so 25. So putting these together, put this in the calculator, 50 times 25 minus 40 times 25, it's going to be 250. So the rate of change of r with respect to time will be 250. And depending on what these units are per year, or probably per year for time, I guess, r is in dollars, so the units on this would be dollars per year. If the units are in years, whatever those units happen to be in. Okay, then we'll do dc dt. Okay, so similar, derivative of x is dx dt, and that one is just 0 because it's a constant. So this one will be pretty straightforward to find that with these values that were given here. So dc dt when x is equal to 40, dx dt is equal to 25. Well, this one doesn't even have an x in it, it's just the dx dt. So 6 times 25, it's going to be 150. And so again, this will be dollars per year, the units. And then for dp dt, we'll need to find what the profit function is. So what is the profit function? P is equal to revenue minus cost, so we'll do that. 50x minus 0.5 x squared minus the cost function, 6x plus 20. Simplify this a little bit. Let's put it in descending order of power, so 0.5x squared. We have a 50 minus a 6, so it's going to be 44, so plus 44x, and then minus 20. So dp dt, derivative of profit with respect to time, again, pretty similar to what we did. So 2 times this is going to be minus 1, so we'll have minus x, lower that to the first power, multiplied by the derivative of x with respect to time. Second term, 44, derivative of x, dx dt, and a constant, we have 0 there. So finally we'll want to plug in the values that were given, dp dt when x is 40, so minus 40 dx dt, we said was 25, and plus 44 times another 25. This is just plugging in the x and the dx dt, the 44 and the dx dt. Put this into the calculator, minus 40 times 25 plus 44 times 25, it's 100. So this is 100. And again, the units here would be dollars per year, dollars per day, depending on whatever the units are for the problem. Okay, so we can kind of interpret these to be, well, rate of change of revenue over time. So basically, the revenue is changing at a rate of $250 per day, per year, again, whatever the units happen to be. The cost is changing at a rate of $150 per day or per year, whatever, and the profit is changing at a rate of $100 per day, per year, again, whatever the units are. Okay? If we had more information about this problem, we could do a better job of analyzing what these answers actually mean. But the way it's written, there's not too much we can actually say about what's going on here other than what I just said about how these rates are changing. Okay?